Let's get started. So in this session, we're going to look at some of the changes that were made to the scoring notes for the APCSP Create Task rubric that was updated after the 2021 rating. Yep, so if you are on PopViz APCSP course, there's a dedicated Create Task unit, which is Unit 5. So check it out with your students. If you don't have access to it and would like to try it out, then at the end of the webinar, I'll be sharing a form which you can submit to get a premium access to PopViz. So here's a little bit about us. So we're PopViz. We provide an online curriculum, professional development in computer science. And I think we're ready to move on, Matthew.
All right, so a little bit about myself. So currently I'm a teacher of computer science at Livingston High School out here in New Jersey. And I have a Master's of Arts in teaching secondary education mathematics. So I'm math certified here in New Jersey, as well as in computer science technology. I also have a Master's of Science in digital forensics and cybersecurity, and I also have a Bachelor's of Science in computer information systems. I also teach at Kean University. I teach 2 courses, one of which is at the 1,000 level, which is like a freshman course called Computing in the Modern Society. I would say that that's pretty close to CSP. We use Python for that, and also kind of like a 3,000 level course with mostly juniors and seniors called Game Design and Development. And I like to tell other people that I teach big kids how to make games in Roblox. I've been a reader for the College Board for the last 2 years. And actually this afternoon, I just got my invitation for the 2022 reading. I did not get invited to Kansas City. I don't think that our course is one that is going to be like in person. The email that I got was that the reading, at least for myself, will be at home. So I'm somewhat glad. Last 2 years have also been at home readings for AP Computer Science Principles. All right, AP Computer Science. So far, I have to say, it's very interesting to me. The last 2 years, the performance task, which we're going to talk about tonight, has actually been extended. But this year so far, despite all sorts of different things happening in the country, my school district that I teach at, I feel like we've been very fortunate that we haven't had to shut down throughout all the craziness that have happened this year. So far, that date for the performance task is still set. It's just set. College Board has not indicated that they will be giving any extensions this year. So it's due May 2nd at 11:59 p.m. Eastern. The end of course exam, that multiple choice MCQ 2-hour 60 question exam, also same date, one administration, paper, no more digital, as it's been in the last 2 years. Also kind of like the week after, which is on Monday, May 9th at 12 p.m. local time. All right, so performance task, 30% of your student's grade. And since we'll need at least 12 hours of class time, for myself here out in the Northeast, we kind of start, I think, compared to the rest of the country, we kind of start the school year a little bit later. So my school district started school on September the 1st. So compared to my kind of computer science teacher friends out west, we're kind of like a couple weeks behind or so. So according to my calculations, and kind of where I am in terms of teaching the curriculum, like my students are kind of currently working through like loops. And then the next big topic, of course, is lists and perhaps object literals if I can get up to there. And then I'm going to devote all of April for them to work on the performance task. This year we happen to have kind of like 2 breaks coming up. We have like a week-long break in February, and then in March we have another break. And then they just announced junior testing in March, which kind of like cuts down on my instructional time. So kind of like I feel like, as it's been in years past, I have to like cut it like really close to the actual deadline. I don't think that's necessarily ideal, but at the same time, I feel like knowing my students, they tend to wait to the last minute to do stuff. So I hope that will bring the best work out of them. So I'm getting like really close in terms of where my students are to starting the performance test, but like we're still working out all of the little nuances about the rows that they need to do, and that's what I'm going to talk about tonight. So the performance test is designed to give students the opportunity to develop a program that solves a problem or perhaps allow for some pursuit of a creative interest. The student should be able to demonstrate the program running and explain its purpose, how it functions, and how it handles input and output of information. So this is in a nutshell what the College Board is looking for in the performance task. Now, just kind of like as an overview, programs typically process collections of data at the same time to help the user gain insight and make decisions. This task also requires students to demonstrate their understanding of these really big concepts in APCSP, data abstraction, using at least one list to hold data to fulfill the program's purpose. And also kind of like really important that I kind of tell students, they must be able to explain all of the code that they're doing. So for example, students must explain why the list manages complexity in the program to demonstrate the importance of using this abstraction when processing large amounts of data. So these are like really big concepts in APCSP. In addition, programs use procedures, also known as functions, to break larger computing tasks into smaller subtasks to make a program easier to develop and test. This task also requires students to use procedural abstraction to write procedures with at least one parameter, which is a really important point, that demonstrates the use of an algorithm, sequencing, selection, and iteration, along with the call to this procedure. So again, really important here, students should be able to explain how the procedure works in detail. And so this is where I kind of like really emphasize to my students, I've had them work on a kind of like miniature performance test so far, like kind of like before loops and also like before lists. And what I explain to them is that, you know, the code is one thing, but the writer is really proving that you understand what the code does. So I think this is a really good way for the College Board to really determine like how much students know and have learned about in this course. So last year was the first time for this particular iteration of the CED. And this was the score distribution for this particular course here. So mean score across the globe, mostly in the US, was 2.99. Standard deviation was about 1.22. Sorry, 1.21. So about 12% got a 5, 21% got a 4. In the middle, kind of like I feel like a very kind of perfect standard deviation. When I show the next slide there, about 32% got a 3, about 20% got a 2, and then about 13.6 got a 1 out of about 116,000 students. That was approximately the same as it was in previous years. This year, I'm thinking probably will be more, just because the College Board last year, I feel like they were very flexible with students. They let students cancel up until the very last minute, even get their money back. And this year, they're not giving students that option. So I think that'll probably make more students take the exam. And I think we're also, as a country, probably in a better place this year than we were last year. So if you look at this chart here, again, kind of made like a graph of it. In this particular AP exam, I feel like if you look at the kind of like curve there, it's kind of like this perfect bell curve that they have going on here. One of the things that I explain to students that in terms of APs, and for many of my students, this is like their first AP course, is that it's kind of like a little mysterious in terms of what actually gets you, let's say, a 1, 2, 3, 4, or 5, because the lowest grade you can get is a 1. But then the next question is, how exactly do you get a 5? And so no one really quite knows the answer to that. There is, again, the 30% for the performance task and the 70% for the multiple choice. But really, how you do on the exam is kind of relative to how the rest of the country also does as well. So I try to get my students to wrap their head around that. It's a little bit hard because, again, it's not like a traditional test that we would have. And let's say you get a 90 out of 100, you know, you got like an A or A minus. This is a little bit like nebulous in terms of like what it takes to get, let's say, like a 5 versus like, let's say, a 3 or a 4, perhaps. All right, so just as a quick overview, we've got 6 rows. students have to get all the different parts of each row in order to get full credit. Just kind of like category wise, row 1 is program purpose and functionality. Row 2 is data abstraction. Row 3 is managing complexity, specifically of your data structure. Row 4 is procedural abstraction. Row 5 is algorithm implementation. And row 6 is testing the procedure. All right, so just to kind of like give you an overview of each row here. So row 1, again, is program purpose and function. And very specifically, students have to write about, describe the overall purpose of the program. Now, something that I picked up during the reading last year, which I feel wasn't necessarily explicitly inside of the scoring rubric, was this question of, with purpose, students had to kind of explain, why did you create this program and what problem are you solving? That was, like, I thought, a very specific criteria there to go along with purpose. Number 2, describe the functionality demonstrated in the video. So students also have to upload a 60-second or up to a 60-second video of their program running. That includes input, that program functionality, and also some kind of output. Now, row 2 is data abstraction. So that's using a list or some kind of collection type, let's say an array or an object literal, or in Python, that's like a map, dictionary, etc. So they're required to include 2 program code segments, explain how data is stored in this list, show the data in the list being used as part of fulfilling the program's purpose. Again, there's like this emphasis on the program having some kind of purpose, identify the name of the variable representing the list, and also describing the data contained in the list. Row 3 is managing complexity. So this is kind of asking students to explain why that data structure is being used, and also how it could be written or how it could not be written without using this data structure. So again, like arrays or lists, or let's say dictionaries, I would say arrays and lists specifically are kind of like fundamental data types for storing multiple values. So students have to, like, again, try to explain how they could, let's say, not write this program versus having it there and managing the complexity of the program. Now, row 4 is procedural abstraction. Now, very specifically, the College Board is looking for a procedure with at least one parameter that has an effect on the functionality of the procedure. So that's a very specific criteria. When I read that, I kind of think that it's saying that you definitely have to have some kind of conditional statement in order to have an effect on the functionality of the procedure. I'll talk about the next row right after with the algorithm. Show where the function is called in the program. And number 3, describe what the procedure does and how it contributes to the overall functionality of the program. So you can kind of see that there's this theme of purpose and functionality throughout all of the rows. Now, row 5 is algorithm implementation. So that is looking for a student developed algorithm. And specifically, I kind of put this for my students' benefit and for your benefit as well. Inside the row 4 procedure, that contains sequencing, which is just a series of steps, selection, which is a conditional, and also iteration, which is loops. And then in addition, explain in detailed steps how the algorithm works in enough detail that someone else could recreate it. So that's like really looking for students to write about the code that they created and then kind of like write it in words, which I found to be a little bit challenging for some students to kind of like articulate exactly what their code is doing. Row 6 finally is testing. So this is testing that function, again, specifically from row 4, and it's asking for 2 procedure calls, and each call must pass a different arguments that causes a different segment of code in the algorithm to execute. In addition, describe the conditions being tested by each call to the procedure and identify the results of each call. Now, this part, I feel like I just had a project with my students And I think the tough part about this row in particular, and this is when I showed the next slide, it's like probably one of the lowest scoring rows, is that this is testing to see if they understand what these procedures, these functions, and calling it and actually passing in different values, which we call arguments. And this is not necessarily explicitly, it kind of depends on the program that you're writing, but it's typically not explicitly inside of the code itself, right? Because the College Board here is asking for input, some kind of processing, and then some kind of output. So although you could have, let's say, some code that, let's say, has these explicit calls differently, this row in particular does not necessarily correspond to any of the code that's actually inside of their program environment. So I found that students have kind of like a hard time wrapping their head around this. So when I'm having them currently working on like functions and like writing different functions to do different things right now, we're like using loops. So I have them having exercises with loops inside of functions. I'm actually emphasizing that they write out the row 4 and row 6 equivalent of calling the function, and then in row 6, calling the function with a particular argument with the output that they're kind of showing me inside of their problem set. So just as kind of overall here, I drew this diagram to help my students. And I think this kind of helps them kind of see versus the scoring rubric, which is like all text. Kind of like flowchart wise, how all of the different rows are connected. So for instance, row 4, row 5, and row 6, in an ideal world, and I'll also talk about how the College Board has kind of made some adjustments to the rubric, row 4 and row 5 and row 6 are all connected. So it's row 5 and row 6 are talking specifically about the function that they specify in row 4. Row 5 is the algorithm, again, contained within the function within row 4. And then row 6, again, is testing that function again, not any other function, the function specifically in row 4. So I hope this diagram helps. So my students are still wrapping their head around this rubric and trying to figure things out. And again, I still have like some topics to teach, but according to my timeline, I've still got about 6 weeks or so to help my students get there. So from the Chief Reader Report that you can access on the College Board website, you kind of take a look at how students scored. Now, at first glance, when I had my students doing this last year, I thought actually row 1 was pretty straightforward. And I was surprised as a reader. And then when I looked at this report, actually it didn't really surprise me because I read the submissions across the country that actually less than half the country got row 1 correct. Only like 47% of them got that. Highest scoring row was row 2. Row 2 is just asking for the list, specifying the list. Row 3 was that managing complexity. And so that was only 35%. That was actually the lowest row there. And I think probably because students weren't really able to explain like how their program could have been written differently. Row 4, again, that procedure with a parameter that affects something within the procedure, 44%. Row 5, that algorithm just kind of explaining it in words, was at 40%. And then row 6, the second lowest, was, again, that function call with different arguments was only 36%. All right, so again, if you kind of like break that down there, lowest ones there, row 3, that managing complexity, and then row 6, testing, seem to be like the hardest ones for students. All right, so again, from the Chief Reader Report, they Chief Reader wrote a summary of what they found in the reading. So some students were able to state the purpose of the program and describe the broader problem that's being solved for the user. However, in the case of game programs, some students incorrectly stated the object of the game, for example, how to win, as the purpose of the program. So that wasn't what the College Board was looking for. And I feel like they're looking for something again, they're kind of like emphasizing purpose and functionality. And I think you have to be very careful if you're going for something like a game to explain that well in order to get credit for row one and all the subsequent rows as well. Some students did not explicitly state what information was going into the program as input and what data was coming out as output. So again, very specific criteria here with the input and the output. And instead describe simply how the program runs. So again, College Board, I feel, really emphasizing that this program has to have a purpose as well as, again, input, what does it do? Output, what do you get out of it? All right, managing data, data complexity and managing complexity. Some responses used other acceptable representations of lists. So for example, like cross-country people used arrays and dictionaries or even trees. Most students were able to identify the list and provide two code segments that demonstrated the creation of the use of the identified list. One of the caveats they mentioned, and also they kind of like put something that I'll show in a later slide. Some students confused creating an empty list with initializing the list with data. All right. Some students were able to use a list in a manner that reduces complexity. However, some students wrote about managing complexity with lists in general, but did not describe how their own program managed complexity with a list. So again, like this is kind of asking the students how this is being applied in their particular program versus just kind of generally saying something like a list contains a whole bunch of, let's say, elements, and perhaps they could have used some variables instead, maybe not. But this is looking very specifically at the program that they wrote. In addition, some students inaccurately described that their program could not be completed without lists when the use of the list was simplistic and could be replaced by a few individual variables. All right, so procedure, abstraction, algorithm implementation, and testing. Again, this is row 4, row 5, and row 6. Some other things that happen. Most students were able to provide the two code segments to describe what the procedure does. Some students had trouble explaining how the procedure contributed to the overall program, particularly when the selected procedure performed almost the entirety of the overall functionality of the program. So in other words, the College Board, again, really kind of emphasizing this idea of abstraction, multiple functions, etc. And it sounds like some students may have just come up with like one really big function that did mostly everything. Some students submitted a procedure with no explicit parameters, which we'll talk about in a little bit, i.e. using global variables to pass data to the procedure, which is something that the College Board was not looking for, but I'll kind of show you in a couple of slides. They kind of made like a little annotation in row 6 about that. When students submit multiple procedures, which even my students did when I had them practice this, the score is based on the first procedure and those that it calls. Sometimes multiple procedures weren't related. That happens like row 6 sometimes. Students were asked to demonstrate sequencing, selection, iteration. In general, most students were able to present a code segment that demonstrated this idea of an algorithm. However, some failed to explain the code in enough detail. So again, they're looking for detail in terms of like the code that students specified in enough detail that someone else could recreate it. And lastly, those two function calls, students were able to describe two calls to the code segments, each calling and passing of different arguments. And again, I'm going to talk about this because this is the new addition to the latest scoring guidelines, explicit or implicit, that cause a different code segment to execute in their procedure. In each case, students were asked to describe what condition was being tested. On the other hand, some students described calls to two different procedures, for example, or described calls to the same procedure with different arguments, different results, but that followed the same sequence of instructions in that procedure. All right, so changes that the College Board made. So I find this to be like a very interesting situation. So if you were actually to go out and Google right now, like AP Computer Science Principles Scoring Guidelines, at least for me, and I know Google results are different for different people and in different parts of the country as well. The first result is this link right here, which is still live, which is the old version of the rubric, which I find a little weird. Version 2, which is the one that you should be using, is linked directly from the College Board website from the AP Computer Science Principles page. And again, I'm going to do a comparison there, but it's a little weird that actually both documents are available, but they're different. I think the College Board should have actually removed this first one here, but it's still accessible. There's like little tiny differences in terms of like, if you were to look at it, you might not notice what's different there, but do be careful in terms of which rubric you're looking at. So again, the one that you should be using is again on the AP Computer Science Principles webpage from the College Board. And then specifically under scoring information, there's a link that says scoring guidelines right above the Chief Reader Report. Again, I also encourage you to read the Chief Reader Report for yourself. You should be using the scoring guidelines and distributing that to your students, not the old one. Now, the way to tell that you're using the latest scoring guidelines is that it has this cover page that says on the top left-hand corner, 2021. And in addition, if you were to look at the very bottom of the page, it also says like this copyright 2021 versus the old version has copyright 2020, which again is, I think, a little bit confusing. Now, I'll kind of like refer to the 2020 versus the 2021 editions when I go through the changes here. So in row 2, in the kind of like first version, I'll call it, of this last version of the CEB, it simply says, do not award a point if the following is true. And it just has this one line here. The use of the list is trivial and does not assist in fulfilling the program's purpose. Now, in the updated version, again, one with the copyright 2021, it specifically adds another decision rule. And it says this list is a one element list. So that's a very specific criteria there. I think that kind of goes along the lines of like the list being trivial. If it only ends up with just like one element in the list the entire time, I think that's not really what the College Board's going for. Now, row 4, again, for the 2020 edition, just has these 2 lines here. It says the procedure must be student developed, but could be developed collaboratively with a partner. If multiple procedures are included, use the first procedure to determine whether the point is earned. In the 2021 edition, they added one more line there, which is going to lead us into like row 6 in a few moments here. So this third bullet point here says that the parameter used in the procedure must be explicit, which I think was the original intention of the College Board. They wanted the parameter to be explicit, being passed in. Explicit parameters are defined in the header of the procedure. Again, this is like classic computer science. You pass in a parameter, you pass it like an argument, you define it with a parameter. And so now the College Board has put this as that third bullet point there, again, explicitly, versus we'll talk about a little bit implicitly. So that they put there very specifically, which I think is along the lines of what they were originally going for. Now, row 6 has a lot more decision rules than the 2020. So you can kind of look, if you were to look at the 2020, there's actually not much here. It just says responses do not earn the point in row 4 may still earn the point in this row. In the 2021 version, it adds all this over here, my thing over here. I'm not perfect. That should have been 2021. Adds these 3 bullet points very specifically. It says, consider implicit or explicit parameters used by the selected procedure when determining whether this point is earned. Implicit parameters are those that are assigned in anticipation of a call to the procedure. For example, an implicit parameter can be set through interactions with a graphical user interface, also known as a GUI. Second bullet point, a condition that uses the procedure's parameter to execute 2 different code segments can also use can also earn this point. And the third bullet point, a condition that uses the procedures parameters to execute or bypass a code segment can also earn this point. Now, when I was reading for the College Board last year, and we were like discussing this new rubric, I have to say I confess that I did not know what an implicit parameter was, and I'm like, are we talking about global variable? And my table leader said, yes, we were talking implicit parameter is a global variable. And I'm like, okay. So again, like that was also mentioned in the chief reader report. I did have to Google just to see, just to make sure, because I was like, what's an implicit parameter? I've taken a lot of computer science courses in undergraduate and graduate. Maybe I wasn't awake for that lecture, but when you Google implicit parameters, you'll get all sorts of interesting results. I got this one from a paper. It says implicit parameters for logic programming, and it says all sorts of interesting things. So it defines implicit parameters are a programming language feature that allows certain arguments to be omitted from a function call. Okay, that sounds interesting. I'm not call it a global variable. I'm not sure. Implicit scope is composed of implicitly passed arguments and bindings explicitly put into the implicit scope. Okay, now they start losing me. Implicit parameters allow parameterization of function methods with extra arguments without requiring those arguments to be explicitly passed through every function called by the programmer. And I'm going like, and then I read further and I start getting more confused. Implicit parameters were originally developed by Lewis et al. As a mechanism to pass an argument to a function deep inside multiple levels of recursion. Then I'm thinking like, wait a minute, are we talking about CSA here? Wait, we don't teach that in CSP. What exactly is the intention here? I'm not sure. And it goes on and on and on. And I just got more confused. But again, we're just looking for, at the end of the day, they're okay with a global variable, sort of. Again, I'll talk about that in a little bit here. So again, what was changed here was, for example, an implicit parameter can be set through an interaction with a graphical user interface. All right, so what this means, if you're coming from, let's say, one of those GUI programming languages that I teach, although I don't necessarily teach on events because I think it's a little bit more or too complex for my students at the moment with everything going on. Let's say we were to have like an on events. This is from App Lab. And I've got, let's say, my VAR credits, and I'm just trying to like get from the GUI, the number of credits you're taking in a semester to go to college. I had students work on like a college cost program, trying to figure out all the different components like tuition and housing and meals, etc., and then kind of like calculating how much it is per semester, and then like how much it costs to go to school for like 4 years. And they were kind of surprised at how much it cost. So again, just kind of like as an example, what the College Board perhaps would be okay for row 6 is, let's say I have my credits variable here, and then I have my function call. I have like Rutgers tuition, and I'm just calling it, just like with no parameters, because I kind of forgot about row 4. And then let's say again, I define my function, and inside of my function, I have my algorithm with my sequencing, selection, and iteration. I can kind of like loop through this here of my list of schools. I ask the user what school they want to go to. Again, I'm getting that credits as this idea of this implicit parameter or the global variable from outside, because I wasn't really quite sure about the requirements that the College Board was looking for, ignoring row 4. And so I get that value and do some processing, and I get a calculation of how much it would cost to go to, let's say, Rutgers. If I took, let's say, less than 12 credits, or let's say if I were to go full-time and take like 12 or more credits, I'd have these different calculations there. So perhaps that's what the College Board had in mind for row 6. I didn't necessarily see that many students still fulfill the criteria for row 6 when I was reading last year. So I'm not sure like what's going to happen this year as well, but I didn't really see that students were able to get credit for row 6 with with that part there. So if the student does not have a function with a parameter, again, from row 4, that's an explicit as they put that bullet point there, they can still potentially earn a point in row 6 by using this implicit parameter. So it's kind of like you lose 4, perhaps get 6. Row 5, I feel, already has something for that. This was in the original scoring guidelines. It has this like very interesting bullet point that says, an algorithm containing sequencing, selection, and iteration that is not contained in a procedure can earn this point. So this is saying that, let's say the student in row 4, when they were supposed to specify the function with the algorithm, with sequencing, selection, and iteration, perhaps just put the code just like outside of a function, just like everywhere. And then saying that they could perhaps get credit for it. So I feel like this is along the lines of what the College Board was thinking after they contemplated the situation with row 6. So kind of like if you think about it, the way I explained to students, row 4, actually all the rows are connected, but in particular, row 4, row 5, and row 6 are all explicitly connected if you want full credit. Because again, row 4 is that procedure with the parameter, row 5 is that algorithm within the procedure, and then row 6 is testing the procedure with different arguments that trigger different things that happen there. But let's say if you did not realize with row 4, theoretically, row 5 could be on its own, right? You just like have that algorithm outside of a function. So row 5 could be on its own. And then theoretically, row 6 could also be on its own, right? Because you don't have to explicitly call that function call. Again, I had, let's say, like credits on the outside. And let's say I were to specify different values of credits. And then they're kind of implicitly being passed into our Rutgers tuition function. All right. So that's about it for me.
So thank you, everybody, for giving us your time. And good luck with the create task, everyone. All right. Bye.
All right. Have a good night.